And now it's the heart. Huzzah! Hi, everybody. Thanks for tuning in to Mr. Ulrich's Land of Biology.com. I'm Mr. Ulrich. In this video, we're going to be looking at cardiac circulation through the mammalian heart. Most notably, we're going to be looking at diagrams of the human heart, talking about the chambers of the heart and the path of blood flow through those chambers. Okay, maybe a couple moments here to discuss where the heart is. Don't want you thinking that it's in your shoe or anything like that. Of course, when we say the pledge, put our hand over our heart, and so we should know that it's located a little bit to the left. Our left lung is actually smaller than the right lung because the heart is moved over into the lung space over there. It's also located a little bit closer to the, not even a little bit, it's located closer to the chest wall, the front of the chest wall, than it is to the back of the chest wall. Okay, so that was probably the easy part. Now we got to do some hard work. These are the parts of the heart, the chambers, and the tubes that connect those chambers to all the necessary parts of the body. The first thing, before we get any further, we need to cover a little bit about anatomical left and right, because this isn't a mirror image. The right side of the heart is actually on the left side of the paper, and the left side of the heart is on the right side of the paper. The heart is a double pump. The left upper and lower chambers are going to work together to pump oxygenated blood, whereas the right upper and lower chambers are going to work together to pump deoxygenated blood. Blood enters the heart, both on the right and the left side, through the upper chambers, or into the upper chambers. These are the right and left atriums. Atria would be the more proper plural. These atria are not as strong. They don't have as thick a wall, as much muscles as the ventricles, those chambers below them, because those ventricles are going to be pumping the blood out through arteries through all those very small capillary beds, and so that takes a lot more work than just kind of dumping it next door. Now, when the ventricles pump, we want to make sure that the blood that's just come from the atrium doesn't squirt back into the atrium. So there are valves that are going to keep the blood moving in the proper directions. The valves between the atria and the ventricles are called atrioventricular valves. The one on the right side is referred to as the tricuspid, and the one on the right side the one on the left side is referred to as the mitral valve, and the one on the right side is referred to as the tricuspid. Sometimes people will be born with a leaky valve. If you have a mitral valve prolapse, that's better known as a heart murmur. That just means a little bit of blood leaks back into the atrium each time, or quite often when the heart pumps, when the ventricles pump. There are also valves keeping blood moving into the arteries. Those are the semilunar valves. And it's important for us to know that there are valves that keep blood going in the right directions, but for a test or quiz situation, knowing the names of the valves would be great extra credit questions. Okay, so we need to talk a little bit about the actual flow of blood through the heart, and we'll talk about the different names of all the arteries and veins that service the heart. You really need to know that there are arteries or veins for each chamber, and whether they're coming to or from the lungs or the body for each one. Once again, the names of these different structures are going to be good for extra credit. Okay, so we might as well start from the body. Blood that's coming from the body is going to be deoxygenated because it's been used up. The oxygen's been used for cellular respiration. It's going to have a little bit more carbon dioxide in it because that's been dumped into it from the lymph, from the draining from around the body cells. So it's going to be higher in carbon dioxide, also from cellular respiration. So that deoxygenated blood comes into the right atrium from the superior and inferior vena cava. These are both veins. They're not called that because one's better than the other. It's just that the superior comes from above the heart, from the head and arms, where the inferior comes from the lower part of the body. So that deoxygenated blood goes into the right atrium, then it goes into the right ventricle where it's pumped out, and of course, where does blood need to be reoxygenated? At the lungs. So these are the pulmonary arteries that are going away from the heart and bringing deoxygenated blood to the lungs. This is an exception to the idea that arteries carry oxygenated blood. So blood is going to go through the atrium, through the ventricle, and out the pulmonary arteries to the lungs to get reoxygenated. From the lungs, they're going to come back into the left atrium via the pulmonary veins. Once again, now we have veins carrying oxygenated blood into the left atrium through those mitral valves into the left ventricle, the largest chamber of the heart because it's got the biggest job. It's got to pump the blood out through the aorta, through even more aorta, that's the descending trunk of the aorta, out to the entire body. Through all of those tiny capillaries, and so that's an enormous amount of work. Your heart is working overtime. Be nice to it. Okay, so we have to remember each chamber, where blood is coming from and where it's going to, and whether that chamber is serviced by an artery or a vein. Okay, so basically what we have here is there's two regions that blood is either going to be going to or coming from. One of those regions is the body. Okay, blood coming from the body is going to travel through the vena cava into the right atrium. From the right atrium, it's going to go into the right ventricle. From the right ventricle, it's going to go through a pulmonary artery into the lungs. That's the second region. So from the lungs, now we have oxygenated blood going through a pulmonary vein into the left atrium, from the left atrium into the left ventricle, and from the left ventricle back to the body through the aorta. If you think this is a lot to remember, it is. I totally understand. There's a nice little mnemonic device that works for this lap. All right. The right atrium starts with an A. The right ventricle starts with a V. The pulmonary artery is an A, the pulmonary vein is a V. The left atrium is an A, the left ventricle is a V. The aorta is an artery A, and then it goes to the body, then back to out the bodies through the vena cava, which are veins V. So it alternates VA, 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 VA. That makes it a little bit easier. All right, there's a couple things also that you have to remember that might help. If you keep in mind that the body is going to deoxygenate blood and the lungs are going to reoxygenate blood, and you remember that the right side of the heart deals with deoxygenated blood and the left side deals with oxygenated blood. With all those kind of 3 or 4 little factoids, you can logic out where it's going to go to and where it's going to come from for each one of those chambers. It takes a little bit of work, takes a little bit of time. Put it together onto some flashcards and see what you can do. All right. A good question on a quiz might be something like identify a chamber of the heart, identify where the blood comes from to get into that chamber and where it goes to, all right, and the type of blood vessel that services that chamber. So you could pick the right ventricle and say blood comes from the left atrium, and from the right ventricle it's going to go to the lungs and it's going to go through an artery. Boom. There's your points. So that heart is working hard, and it's going to need quite a bit of oxygen. It's going to need fuel. It's going to produce a lot of waste products, so it's going to need its own set of arteries and veins itself. It can't get the material that it needs from the blood that's going through the chambers. It's not really set up for exchange of materials the way those capillaries are. So the heart has its own set of coronary arteries and coronary veins. Alright, I think that's probably enough for this video. Thanks for tuning in. I hope you're making good use of the supporting material that's available on the website, MrUlrichLandofBiology.com. Of course, you can always email me if you have any further questions, if you have any feedback, constructive criticisms, or anything of that nature. Also, these are works in progress, so any students who want to submit material that might be appropriate to include in any of these videos, that's certainly a good extra credit idea. So thanks again for tuning in. I'll see you in class.